Scientists' DNA tested the Dead Sea Scrolls and found something nobody expected. Not in the ink, not in the words, in the skin. The animal skin those ancient manuscripts were written on. And what that DNA revealed quietly dismantled a theory the academic world had treated as settled fact for nearly 70 years. I'm Arif Hassan, and this is AH History. This story starts in a desert cave in 1947. A young Bedouin shepherd named Muhammad ed-Dib was wandering the limestone cliffs near the Dead Sea looking for a lost goat. He threw a stone into a dark cave opening, expecting to hear the animal. Instead, he heard a clay pot break. Climbing in, he found large sealed clay jars containing ancient leather scrolls wrapped in linen. Between 1947 and 1956, excavations across 11 caves in the area produced roughly 25,000 fragments, pieces of around 1,000 different manuscripts, including the oldest known copies of biblical books like Genesis, Isaiah, and Psalms, alongside religious laws, hymns, and community rules. Carbon dating and paleography placed most of them between around 250 BCE and 68 CE. For decades, one explanation dominated: the Essene theory. Ancient historians, including Josephus and Pliny the Elder, wrote about the Essenes, a strict ascetic Jewish community devoted to copying sacred texts. The nearby site of Qumran showed signs of community habitation. Several scrolls contained detailed communal rules, and one, the War Scroll, described an apocalyptic battle between the Sons of Light and the Sons of Darkness, the kind of worldview associated with a separatist religious group. A distinct solar calendar found in some scrolls, differing from the lunar calendar used at the Jerusalem Temple, reinforced the idea of an isolated, self-contained sect. For nearly 70 years, museums and textbooks presented it as settled. The Essenes lived at Qumran, wrote and collected the scrolls, and hid them when the Roman army advanced around 68 to 70 CE. But some things didn't quite fit. Handwriting varied enormously across fragments, from highly trained professional scribes to much more ordinary hands. An odd inconsistency if one dedicated community produced everything. Some scrolls turned out to be older than the Qumran settlement itself, and the collection contained two distinctly different versions of the Book of Jeremiah, one closely matching the modern Hebrew Bible, the other shorter with different chapter ordering, an odd thing for one tightly organized community to preserve side by side. Then in 2012, at Tel Aviv University, molecular biologist Oded Rekavi and Dead Sea Scroll scholar Noam Mizrahi ended up seated next to each other during a new faculty orientation. In conversation, Mizrahi mentioned something everyone in the field already knew but had never quite applied this way. The scrolls were written on parchment, animal skin. Rekavi realized parchment contains DNA, and the question became whether any of it had survived 2,000 years in the desert. Desert conditions are actually relatively favorable for DNA preservation compared to humid climates, since low moisture slows the chemical breakdown, so there was real scientific reason to think something might remain. The challenge was sampling without damaging irreplaceable manuscripts. Rather than cutting into written text, conservators from the Israel Antiquities Authority took extremely small samples, under half a square centimeter, from blank edges of fragments where there was no writing, using gloves and a fine scalpel under strict conservation protocol. The samples went to specialized ancient DNA labs, which require extraordinary contamination control, since a single shed skin cell from a modern researcher can corrupt a result. The labs used UV sterilization and positive pressure environments to keep outside DNA from entering. Even with all of that, much of what they recovered was too degraded to use, and the project took roughly 7 years before results were solid enough to publish. When the study appeared in the journal Cell in June 2020, most findings confirmed what researchers expected. Almost all the sampled fragments were sheepskin, unsurprising since sheep, hardy and low-water animals, were well suited to the Judean desert. Then came the finding nobody anticipated. 2 samples turned out to be cowhide, and both belonged to fragments of the Book of Jeremiah. That matters because cattle require far more water and grazing land than the Judean desert around Qumran could ever provide. Cow husbandry in that environment is essentially impossible, which means those cowhide fragments were produced somewhere else entirely and carried to Qumran afterward. Crucially, the 2 cowhide fragments belonged to 2 different copies of Jeremiah, reflecting different textual versions of the same book. meaning this wasn't just proof of imported parchment, it was physical, genetic confirmation that distinct textual traditions from different geographic origins had ended up in the very same cave. In one specific case, a cowhide Jeremiah fragment had previously been assumed by scholars, based on handwriting, to belong to the same scroll as a nearby fragment. The DNA showed that other fragment was sheepskin, from a genetically distinct source, disproving the connection outright. The team pushed further, using mitochondrial DNA, inherited maternally with little change across generations, to compare fragments against each other directly. Every animal carries a unique genetic signature, so fragments from the same individual animal show high similarity, while fragments from different animals diverge. This let researchers determine, with actual genetic evidence rather than handwriting comparison or scholarly judgment, which fragments genuinely belong to the same scroll and which didn't, confirming some long-standing assumptions and overturning others. Groups of fragments with related genetic profiles pointed to shared production centers, while divergent DNA patterns pointed to different herds from different regions ending up in the same cave. This reframed something that had puzzled scholars for decades: the sheer diversity within the Qumran collection. A library belonging to one isolated, tightly organized community would be expected to show real internal consistency in its theology and textual choices. Instead, the scrolls contain texts that seem to contradict each other, multiple versions of the same books, and a range of genres inconsistent with a single community's output. Multiple geographic origins, now backed by genetic evidence, offer a natural explanation for that diversity. This lines up with what many scholars now consider the most compelling account of how the caves came to hold such a varied collection, sometimes called the Geniza theory. In Jewish religious tradition, sacred texts containing the name of God cannot simply be discarded. When no longer usable, they're placed in a Geniza, a dedicated space where they can rest with dignity. Many historians believe the Qumran caves may have served this function during a moment of crisis. When Rome destroyed Jerusalem between 68 and 70 CE, communities across the region, Jerusalem sits roughly 20 kilometers away, may have brought their most sacred texts to the caves for safekeeping, from synagogues, family collections, and religious centers across a wide area. That would explain the geographic diversity the DNA revealed, the inconsistent handwriting, the multiple textual traditions, and the presence of material that simply couldn't have been produced locally. This doesn't diminish the Essenes' historical importance. It expands what the discovery represents, from the private library of one sect to a cross-section of Jewish religious life across the entire Second Temple period. The Songs of the Sabbath Sacrifice, a liturgical text describing angelic worship, adds another layer of evidence. Copies turned up not only at Qumran, but also at Masada, the mountain fortress that fell to Rome in 73 CE, and DNA testing showed the Qumran copies came from different animals, consistent with independent copying in separate places, rather than a single scriptorium, which tells you this was a widely shared text, valued and preserved by multiple communities independently, not the private document of one group. The research hasn't stopped at that 2020 publication. Scientists are now building a broader ancient animal DNA reference database, aiming to eventually trace a fragment's parchment not just to a species, but to a specific region, giving scholars a level of geographic precision handwriting analysis alone could never provide. Researchers are also combining this genetic work with multispectral imaging, which uses light beyond the visible spectrum to recover faded writing invisible to the naked eye, cross-referencing newly readable text with the DNA data on where its parchment actually came from. What the DNA work demonstrated most clearly, beyond anything about the scrolls themselves, is something about how scholarship changes. For nearly 70 years, one explanation was treated as essentially settled. It took a chance conversation between a molecular biologist and a textual scholar, and one simple question nobody had thought to ask. What were these scrolls actually made of? To reopen a debate an entire field had considered closed. If you want more history covered with the real evidence and the real complications intact, follow this channel because there's a lot more of this kind of story worth telling properly.